In this video, we'll continue our discussion of cylindrical coordinates with another example. This example is a bit weird. So we find the volume of T. T is a solid bound by, okay, that's a sphere. And then this thing may not be obvious. Oh, I actually want to change this problem. I meant to do that. Forgive me for doing it right here. Yours is probably already fixed. So this should be a -6. It just didn't work out great with that 1/5. All right. So first thing I'm going to do is I see two functions. I want to get them equal to z. And we're going to work with that. So z here is the plus or minus, and I'm going to leave that off for a moment. We got 16 minus x squared minus y squared. Or I'm going to rewrite this as z equals the square root of 16 minus x squared plus y squared, like that. You can see where I'm probably going with that in a little bit. This one, if I were to solve this for z, I got z equals -1/6 x squared plus y squared. Okay, so this is we need to think about this. This is a cone. I lied to you guys. That is a paraboloid. That is a paraboloid. Paraboloid. Okay, and it opens down. Opens down because the negative. The 1/6 is going to make it wider. We don't care. It opens down. It is at the origin. It's not moved up at all. The other thing is a whole sphere. If I look at it like that, that's a sphere with radius 4, but the plus and minus is going to give me hemispheres. But if I want it to open, I'm opening down here, and I want to capture it with the lower half of the sphere, this is going to have to be negative. All right, so we have that. That doesn't tell us much as it stands. But what we're going to do is we're actually going to plug the two into each other. Let me move this over because I want to make this a little more obvious. I'm going to put that over here. If I take this function and I replace x squared and y squared with what's there, I get z squared. I'm just going to flip this. Minus 6z equals 16. I replaced x squared plus y squared with -6z. As you notice now, we only have things in terms of z. And we haven't done something like this before, but this is going to tell me the two z's that they intersect at. This thing factors. It's a z minus 8 and a z plus 2, I believe. Yep. Right, so we get two values here, z equals 8 and z equals -2. But if we think about our functions, they both open down. So I really don't care about z equals 8 because that's above the xy plane. This is going to be where they intersect at -2. Now, what does that tell me, though? Because so far, we got both functions in terms of z. Then I set the two functions equal to each other by plugging one into the other. And I found, hey, they intersect at z equals -2. Well, that means I can just take my sphere now and plug in x squared plus y squared, and then plug a -2 in for z. So -2 squared equals 16. And that's going to give me x squared plus y squared. That's going to be a 4. If I subtract that over, that's a 12. So the radius of this sphere is the circle projected onto the xy plane is going to be 2 squared, so 3. I already have a picture made. I'm just going to paste it here, hopefully. Yeah, okay. Let me shrink this up a little bit. All right, there is my z equals -2. That's what we would get. This isn't on the xy plane. It's below it at -2. This is where the two surfaces, the sphere and the paraboloid, would project, or intersect, but it's projected onto the xy axis to help me find r's and thetas. Okay, so we have that. Let's try to set up our bounds now. So z is caught between, well, I got to figure out which one's on top and which one's on bottom. What I can do is just pick a point inside my sphere, or inside my region, I mean. Well, the region is, I have a 0, 0. That's what I should plug in. If I plug 0, 0 into this, right, 0, 0, I get -4. If I plug 0, 0 into this, I get 0. So, this is the bottom. And this is the top. Also notice I can replace those x squareds plus y squareds with r squareds. So I know the bottom is going to be negative. Probably need to scoot this over a bit. Negative square root of 16 minus r squared. The top is going to be -1/6 r squared. Now I'm going to bound r. I just look at my region over to the right. That's between 0 and 2 root 3. Or square root of 12 would work too, doesn't matter. And then theta is our last thing. Well, it goes all the way around. You can see it in my picture. That's 0 to 2 pi. So we have our bounds now. We just have to set up our integral. All right, so the volume is going to be theta from 0 to 2 pi. R from 0 to 2 root 3. Z from negative square root of 16 minus r squared. And then the top bound is negative 1/6 r squared. We're finding volume, so the integrand is 1. And then don't forget, we're going to cylindrical, so you have to add that r. dz, dr, d theta. If you would like an answer to this to work out, I'm not going to work it out. It's a pretty straightforward integral. It's just like polar, except for the z component, which is very easy to do because there is no z component, so you just introduce a z and plug them in. If I work this out, the volume here is going to be 76 over 3 pi.